Kinematics problem set number 4. In an attempt to save the world, Batman and Robin are trying to retrieve an explosive placed at the bottom of a dam. Batman is on top of the dam with a powerful catapult that will send the explosive into outer space. Robin is at 100.0 meters below the explosive, basically at the bottom of the dam. He throws the explosive upward at a velocity of 40 meters per second for Batman to catch. Because Robin is not a blah blah blah, he will now reach Batman. The explosive will now reach Batman. Batman tries to ties a 42-meter length rope to his waist and jump from the dam 1.0 seconds after Robin uh, throws the explosive. How long will Batman free fall before he catches the explosive? Now, you can see there's a lot of extra unnecessary information in this question. It's important to cross them out so you don't get confused, such as this sentence. And this part in brackets. As long as this sentence, because it means nothing to me in this question. After that, we can first draw a diagram of what's happening. So that part is top of the dam, top dam. This is bottom of the dam. And guess what? This distance from here to here is 100 meters with 4 sig figs. You have one guy jumping down at an initial velocity of 0 because that's a free fall. Acceleration equals the gravity. And you have this guy over here throwing something upwards at a v1 of 40 meters per second up, and an acceleration of gravity pulling it down. Therefore, we have two intervals, basically two items to set up. I will say B for Batman in red. It's V, keep writing V0. V1 equals 0. V2, don't care. A equals, I will set up equals positive. I'll set that up on the bottom as well, but basically I'm trying to write 9.81 meters per second squared. Then delta t. There is only one delta t, but since he ties around his waist and jump 1.0 meters after he throws the explosive up, the time for Batman will equal to the time of TNT explosive plus 1. And there's also this variable of dB, which is not important at all, but we'll get into it in a bit. Now in blue, I have my TNT explosive. V1 would equal to 40 meters per second up. So that's positive. V2 equals nothing to me. The A are all the same because it's one-dimensional. It's negative 9.8 meters per second squared, basically gravity. You have your delta T, but this one's for TNT. And you have your delta D TNT. Now, how do I set this up? I'm trying to find how long it took, basically time. So what I can get from this is basically the distance of free fall plus the distance of throwing upwards will equal to 100. That would mean 100 equal to, because it's going negative this way, positive that way, I will have a negative Batman negative Batman's distance, and I will plus a positive displacement for TNT. If I was to rearrange that in a better way, it would just be putting this here. Now I'll get rid of the negative sign. That looks better. We'll work from here, and I'll continue my blue representing TNT down to d TNT. I'll put the vector symbols there anyways. It will equal v1 delta t plus half a t squared. That will give me delta t TNT by subbing some numbers, 40 delta t minus 1/2 of 9.81. I'll combine that into 1, and if you recognize the number, it's 4.905 delta t squared. That's for TNT. Now I'm just going to copy the same equation for Batman. v1 delta t plus half a delta t squared. Now Batman has initial velocity of 0. I don't even care. I don't even bother writing it. And because acceleration is always negative, it will have the same acceleration, and the time for Batman will be a little special. It will be delta t of TNT. I should write that in blue. Delta t of TNT plus 1 unsquared. There I have my equation 1 and 2. I will work by subbing this in. Actually, you know what? Let's make this 1, this 2, this 3. Sub 2 and 3 into 1. That's going to give me 100 equals to the portion for explosive, 40 delta t TNT. Forgot to write TNT here. Minus 4.905 delta t squared for TNT. And I would, the whole thing minus, in brackets, Batman, 9.8. My notes are messed up, but negative 4.905 multiply by, I would expand this a little, so it's delta t squared of TNT plus 2 times delta t of TNT plus 1. Bracket back with red, then black. Okay. Now I will just write everything in black just to simplify my life and spare you some time. This would equal to 40 delta t TNT minus 4.905 delta t squared TNT. Then plus, after simplifying this a little, I will get positive 4.905 with a t squared TNT, then plus 9.81 delta t with nothing, and plus 4.905. Okay, let's simplify this even more. You can notice that I can cancel these two terms, then be left with something simpler to work with. I can common factor these two because they're in single power. That means I will have bracket 40 plus 9.81 bracket multiplied by delta t of TNT, then plus 4.905. Let me pick up my notes. I'm going to solve everything in 2 steps. This will be 100. You move this over here by subtraction, 4.905. Subtract divided by whatever you have over here, and just leave the time alone on this side. So it's going to be 49.81. Cool. Equals delta t of t and t. Simple, eh? Now plug it into your calculator. I got this number according to my notes. Seconds. That is the time when they meet each other. So basically, Batman from here falls 1.9 seconds, and while this TNT goes up, they meet each other at this time. And therefore, I can draw my statement. Shoot, did I forget to write A? Yeah, that's my analysis. The whole thing would be shifted downwards. Therefore, Batman will free fall for how many sig figs? I have 4 over here, 3 over here, 2 over here. By the way, 42 is very unnecessary, and there's 1.0 over here. If you're confused, this number is not used at all, so it doesn't contribute to significant figures. But 1.0 is used, so your lowest term for significant digits is 2. That will bring you to, for 2.0, actually 1.9 seconds.